Now I'm going to explain armature reaction of an alternator, right? So first I'll be explaining the definition. So the effect of armature flux on the main field flux is called armature reaction, right? Is called armature reaction, right? It depends on the magnitude of the load and the power factor, right? So that is the effect of armature flux on the main field flux. So that is nothing but the armature reaction. And you have to remember one particular important thing here, that is in an alternator EMF E always lags phi m by 90 degrees, right? This is very important terminology. This is very important point, right? So now let us concentrate on the effect of armature reaction under different power factors, right? First one is unity power factor. Unity power factor in the sense what both voltage and currents will be in phase, that means phi equal to 0 over here. So what is going to be happen? I told you here in an alternator EMF E always lags phi m by 90 degrees here. So EMF E always lags phi m by 90 degrees, right? So due to this current IA will give us some flux, that is armature flux phi A, and that phi A and phi m, so the phase difference between phi m and phi A are completely 90 degrees. And if you clearly observe over here, the value of phi A in the direction of phi m, right, the value of phi A in the direction of phi m is given as phi m cos 90. It is nothing but what? 0. As it is 0, as the phi A is 0, so what is going to be happen? So it is either demagnetizing or magnetizing. So here it is known as, the effect of armature reaction is completely what? Purely cross magnetization. What? Purely cross magnetization, right? Next, coming to the ZPF lagging over conditions, so it is completely it occurs in inductors, right? It occurs in pure inductor. So in an inductor, current lags the voltage by 90 degrees. So here it is 90 degrees. So current is going to be lagging by 90 degrees. So in this position, we are having current produces armature flux phi A, right? So obviously phi m is going to be lead E by 90 degrees, right? Lead E by 90 degrees. So the overall phase difference between phi m and phi A should be what? Is 180 degrees. That means the resultant resultant flux is going to be decreasing. So as the resultant flux is going to be decreasing, it is the armature reaction is nothing but what? Purely demagnetization, right? Next one is ZPF lead. So in the leading condition, IA is always leads voltage, in a leading condition, and it occurs in pure capacitor. It occurs in what? Pure capacitor, right? So pure capacitor. So that means what? Here phi m and phi A are in phase, so are aiding to each other. That is, the resultant flux will be increasing. As it is increasing, it is what? Purely magnetizing condition, right? Thank you.